Is my screen visible to you guys? Yeah. Okay. Now let's launch Rhino. Some of you texted me asking whether Rhino 6 is fine for your purpose. That's fine. Rhino 6, Rhino 7, any of those versions are fine. Although if you're downloading it, or if you've just started downloading it recently, Rhino 7 is the version that you will be getting. Okay. Now we had covered the basics of modeling. Let's just start uh, by launching Grasshopper. There are two ways of launching Grasshopper from Rhino. The first way is this icon over here, this one. And the other way is to go to the command panel and type Grasshopper, and it'll launch Grasshopper window for you. As soon as you open Grasshopper, it's advised to have a split screen setup. Now that's a personal preference, whatever you like. I prefer to keep the Rhino window on the left and the Grasshopper window on the right. And I prefer to work in the perspective viewport. So double click on perspective, that's the setting. Now, when you start Grasshopper, I have a lot of options over here. That's the menu bar. When you are using vanilla Grasshopper, when I say vanilla Grasshopper, it's the basic Grasshopper that you get with Rhino without any plugins. You will see very limited options over here. So let me just explain the user interface first. Right at the top is our menu bar. So you've got the basic things like open a new file, new document, recent files, the usual stuff that you get with any software. Then you have the editing bar, copy, paste, arrange, modify, create. We'll come to this when it's required. And then display settings, solution, help, and all those kind of things. The second area of this user interface is the toolbar. So all of this is our toolbar. Now the toolbar in a default or vanilla Grasshopper will comprise of these 9 menus, these 10 menus. So you'll have params. Then you have another tab called maths. And these tabs will have some other components associated with it. Then sets, vector, curve, surface, mesh, intersect, transform, and display. So these are the 10 default toolbar options that you see. And then further to this, there will be many other commands that you can play around with. The third section is the canvas bar, which is over here. Now, in this user interface, the area where we will be scripting is called the canvas, which is over here. So that's the canvas. And to manipulate things, how they appear on the canvas, are controlled over here using the canvas toolbar. And lastly, then the canvas itself. All right. So what we covered last time in Rhino were the basic geometry types. So we had the points, the lines, the surfaces, etc. So let's see how to do those things in Grasshopper. Firstly, why Grasshopper? What is, when we say Grasshopper is a visual scripting interface, what do we mean by that? Grasshopper is a node-based system where you have components like point, and then you have components like surface, you have components like mesh, and all these different components. And if you notice a particular component, it has these two earlobes sort of things. So these are the connectors where you can input a data and output the data from these components. And each of these components have certain commands embedded in it, which will execute based on the input data that you receive and give you an output. And each of these components work in different ways. There are three kinds of components. There are operational components, there are input components, and there are data type containers. Let me show you all three of them with an example. Under params geometry, all of these are container components. That means they will contain data types. So if I pull up a point, this is a container that will store points in it. A crucial setting for us while we are learning Grasshopper would be to go to display settings, toggle full names, draw full names, and toggle draw fancy wires and toggle draw icons. I will uncheck this one. So I don't see the icons and I only see the name. So it's easier for me to understand what each component is. I suggest you keep these settings as well. So keep it at draw full names and draw fancy wires. Okay. So this is a container component. There is a container component called surface, and this container component, as the name suggests, will store surfaces only. It doesn't understand what a point is. It doesn't understand what a line is. It only understands what a surface is. So these are data type specific. And there are a lot of data types and specific containers for them. We'll touch upon them one by one. The other kind of component is, so let me just keep that on screen. The other kind of component is a operational component. So if I bring up construct point. Construct point is an operational component which requires, as you can see over here, 3 inputs. And the data type of these inputs are, if you hover over this, it says it requires an X coordinate. So every operational component requires some input, and those inputs, the kind of data that you require, can be understood by just placing your mouse over it and just leaving it over there, and it will start explaining what kind of data it requires. So if you read over here, it says this input requires an X coordinate. Now, what's the data type for an X coordinate? What's the kind of data that we provide over here?
Decimal number, decimal.
Some kind of number, yeah, a decimal number. Now, I can provide a number by right-clicking over here, going to set number and suggesting a value 10. So I see automatically on my screen, I have a point created at X 10, Y by default is 0, and Z by default is 0. So we have a point on the screen over here. The dot on my screen appears to be a point, whereas by default in the settings of Grasshopper, a dot appears as a cross. So I've just changed that back to a cross for us to be on the same page. Okay, let's try and change the Y coordinate as well. So we go to set number and change this to 10. And now the point is over here. If you do the same thing over here, go to set number and press 15. We have a point in 3D up there. Okay, but this is too tedious for us to do it in this manner. An easier way to have this data input would be to use some kind of a slider, numeric slider over here that will help us change the numbers easily. So there is under params something called, in inputs we have a numeric slider. Now numeric slider has a range, which is the lower number and the higher number between which we can set any particular number. By default, when you bring in a numeric slider, the range is set to 0 to 1. So the slider cannot cross that barrier. So we can plug this in. If I want to copy it, we can do Control C, Control V, plug that in, and so on. You can also rename these sliders by clicking over here using right click. You see this option. You can type X coordinate, Y coordinate, and Z coordinate. Okay. And by manipulating these sliders, you can affect some change in this point, in this location of this point. Now, if you want to manipulate the range, that is the lower and the higher value of this particular slider, we need to right click on the slider and go to edit. When we go to edit, we see a bunch of options. Let's understand what these are. Firstly, the rounding off. In computational design or any programming language, decimal numbers are not known as decimal numbers, but there's a terminology for it, and it's called floating numbers. It's floating. Okay. So R over here means that you have a decimal point number, which is a floating point number. N means it's an integer. Currently it's set to R. That's why you see a whole range of numbers between 0 and 1. If I set this to integer and press OK, you can only have the option of either 0 or 1. You have no intermediate options. When we go and edit this, you can see an option for minimum and maximum of this numeric domain. Currently, the minimum is 0 and maximum is 1. You can double click on it and set this to 100. And that's the new numeric domain. We can go back and make it rounding, and this will again change it to floating point number. You can control the number of decimals or the numbers after the decimal point by moving this slider. So you can see the number of digits after the decimal is changing when we change this option over here. The third one is even numbers that will only snap to multiples of 2, and O is odd numbers that will choose the odd numbers within this range. Pretty self-explanatory. Okay. Now let me come back over here. I'll delete the two sliders. Bring this over here. And now we have control over this point using the three sliders. Okay. There is a third way of getting a point within this point component. So either this point output from here. Now, if I hover over this as the output, I can see the output is one locally defined value, and the value is these three numbers that is defining the point coordinate. And that can be an input over here. So when I bring up the point component, it shows as an orange colored component. Orange color is a visual indicator that this component is missing some kind of input. Okay. So that's the error that it's showing. So if when we give this an input, it has turned white or this silver grayish color. And that's how we know that it's fine. It has all the relevant inputs required and it's working now. If you have a point and if you don't want to construct a point, there's another option where you can right click and you can select at set one point. With this option, you can click anywhere on the Rhino window and you can see that, wait, set one point and I can click anywhere. And now this point is taken as an input for in this container component. A third way to do this would be to set a point on the screen, create a point component. I will clear the values so that it's again empty, and then set one point and I select this point. Now, the difference between the two is that when I had used point component and set one point to create a point on Rhino, it creates one locally defined value. When I reference a point, so there is a point created and I have referenced it in this point container component, I see a referenced point as an output. And if I move this point anywhere on the screen, the reference point location will also change. Let me hide this, and you see the point still being over there. This is very handy when you want to draw certain geometry on the screen in Rhino first by your hand and then operate on it using Grasshopper. Okay. Now we have a point over here and we have a point over here. The next thing we can do with 2 points is to create a line between them. The way Grasshopper's menu is set up, it's pretty self-explanatory, wherein params has all the parameters. So we have all the container components over here. We have some primitive data type over here. Primitive data type is the name used for data type, which is the basic data type used in programming. So Boolean is a data type which is either true or false. It's binary. That's how the entire computer language works. It's ones and zeros. Then the other basic data type is integers, because computers work with numbers and every geometry is a combination of numbers. Then you have the floating point number as the basic data type, and then you have the text as the basic primitive data type. Then you have some other data types which are a combination of these primitive data types. So you've got color, you've got domains, culture. Most of this does not come into play that often, and whenever it does, we will touch upon. Then you have the input tabs, which have different kind of inputs. We looked at number slider. You have something called the panel. So a panel is used to read inputs or assign outputs or create nodes. I can pull up a panel, take this output into this panel, and I can read what is the output on the screen. We can do the same over here, and it gives us the output, and this one will give us reference point as the output. Okay. You can resize this, you can recolor this, you can change the font, just right click, and there are multiple options to do whatever you want to do. Then you have button, Boolean, toggle, and the slider. I will touch upon these as and when we require them during the exercises. Okay. There is an entire section based for mathematical operations, and these are very crucial, which we will be again touching upon. But mainly you have all your operators, which are the addition, division, multiplication, negative, power, subtraction, all the basic ones, equality, larger than, smaller than. So let's just try a few of them. Let's say we do addition, and I take these two number sliders. Every component that you bring in, and this is for you to start learning it on your own as well. You need to hover on the input and you need to understand what's the first input required. It says first item for addition. Now, obviously, you can't add two texts, so you will be adding numbers. So you take in a number, you take in another number, and the result will come out over here. Now, what kind of data is coming out over here? Is it an integer or a floating point number?
Floating point.
It's a floating point, yeah. So I can take a panel, I can see it over here like this. I can also bring up an integer and I can put it in over here. And now what happened? Why is it rounding it off? Our result is 68.23, but when I pass it through this, it's rounding off the number. What's happening?
Because you selected integer. So
Yeah, I selected integer. That's why the container and the way data is coming out, you need to be very clear about what kind of data is coming out. Okay. So if I choose a number is floating point number, and that's when we get 68.23. There are other mathematical operators which we will touch upon when required. Okay. Let's come to the crucial one, which is creating a line. So when I come to the curve option in the toolbar, I'll look for line. Now, line is a primitive kind of a curve. It's primitive is a terminology used to define basic geometries in a particular geometry type. So line, as soon as I click the primitive tab, under that I can see various ways of creating a line. Just like we had various options of creating a line in Rhino. Similarly, you have various ways of creating a line in Grasshopper. I have 2 points with me, so I want to find a method where I can use 2 points to create a line. So we'll go to primitive and we'll see fit line, create a line between 2 points. Now it explains how this method works. So we go to primitive, I click on the line, I bring it up. When you hover the mouse over the name itself, you can read what's the intended use of this component, which is create a line between 2 points. And when you're starting off in Grasshopper and trying to learn it, bring out a component, read what it does, and then read the kind of input required. And that's the best way of learning it. Okay. So it requires a start point. I have a point over here. Let's assume that's the start point. And then it requires an end point. And this point, I'm going to use it as an end point. And the output is a line. So out of the geometry tab, I'm going to pull up a line container component. And that's, now this is not required. Like you can also take this line and use and this as an output or an input for some other component afterwards. But just to keep things clear, for now, I'm using these container components. We won't be using these as often as we move ahead. Now that's the line for us. And if we manipulate our point, which is if I take this point, which is a reference point, and if I move it on screen, you can see that the line itself adjusts accordingly. If we do the same thing out of construct point, wherein I move all of this, I copy this a couple of times. So I'm going to select the entire thing, Control C, Control V. And I go to curve, primitive, line between 2 points. That's the start, that's the end. And you bring up a line component, and if I keep this on, and I don't see a line. Why is that? This line is being created using this. So let me just delete this. I don't see a line.
Both the points, the location is the
Yeah, both the points, locations is the same. So it's creating a line of length 0. And it says it's an invalid line. Okay, so let's just change this around a bit. And that's a way of setting up a parametric way of creating a line. Parametric simply because we have a bunch of parameters that are governing the way this line is drawn. All right. Couple of things that you would notice by now is that Grasshopper works with an additive display setup, wherein whatever you draw on the screen will keep appearing on the screen and it will keep adding on. So we constructed points, the points appear on the screen. The point container will also display the points on the screen. Then you created a line, it's displayed on the screen. If I take another point and I move this across and I create a line between these as well, it will keep piling on data and it will keep displaying everything that is being drawn over here in the canvas. And a lot of times we don't want to see all the data, but we only want to see the final output geometry or very specific geometries. So to control what is visible on the Rhino viewport, we need to understand how these viewports work. By default, you have this option selected, which is draw shaded preview. There is an optional where you can only draw preview geometry for selected objects. When you select this option, you'll only see the geometry that you have currently selected. It's great because it reduces the computation time. It reduces the amount of RAM used by a computer because you're only drawing things that you want to see and not drawing the entire geometry. But it can also be a bit annoying when you always have to keep selecting it. So another way of controlling is to keep draw shaded preview on, and there's a third option. Now this option is not available in Rhino 6, it's only available in Rhino 7, which is draw a preview geometry on canvas to exclude objects. So if you select this option, you can left click on the screen and keep the mouse button pressed, and you can create this boundary, and the components that lie within this boundary will be displayed and rest of the geometry will not be displayed. This is a quick way of isolating and just previewing geometry that you want to preview. And once you're done previewing the geometry, you can press escape and you can see everything else. A third way of controlling this is to select all the geometries that you do not want to preview and go to display settings and go to view settings. Okay, sorry, solution, and then you say preview selected off. As soon as you do that, you see that all the components that are previewing a geometry or drawing a geometry on the viewport, they turn into dark gray. And that's how we know that these previews have been disabled. You'll notice that these input geometries don't change in color because these are not drawing any geometry onto a Rhino viewport. Another way of accessing this option is through the option wheel, which is over here. Now you can bring up this option wheel by using the mouse wheel button. So if you press on the mouse wheel button, you can see this option wheel coming up. So if I have this geometry, if I go to preview selected on, we can select this geometry, press on the middle mouse button or your mouse wheel. You can go on to any of the options that you want. So these two options control the preview. This one says enable preview. This is disable preview. So if I click on this, it has disabled the preview. And if I select all of this and center mouse click and enable preview. Great. Let's see whatever the options do we have on the screen. Everything that we're drawing over here on the screen or in Grasshopper is within Grasshopper till now. Nothing is in Rhino. Rhino viewport is being used as a viewport only. It's just being used to view the geometry. Nothing has yet been drawn or brought into Rhino itself. If you want to bring something into Rhino, you'll have to bake a geometry into Rhino. To do that, you can select a particular geometry. You can right click on it and you can select this option called bake. When you select bake, it will ask you which layer do you want to bake it into. So let me say I want to bake it into default layer. It will also ask you whether you want to group this geometry. It's a single geometry, so there's no point grouping it. But if you have multiple geometries, you can have the option of grouping it as well. And some other options of the kind of display mode you want to set it to and other stuff, which I'll leave you to explore. And then you press OK. And as soon as we do that, you can see that this point has been baked onto a Rhino window. Let's try this for the line as well. So we select these two lines, right click, bake, default, group, okay. And we have these two curves on the Rhino window. All right, now after baking, if I minimize this, I can still see things on the screen. The next thing I would like to cover is how you save files in Grasshopper and Rhino. Let me remove this construct point. It turned orange, and I will be selecting one point from Rhino window, and I will delete this. Okay. So that's our Grasshopper definition at the moment. I'm going to save this file by going to the file, save document, and I will say lecture 3, introduction to Grasshopper, and I save this. Now I will close the Grasshopper window and I'll close the Rhino window. Save changes, no. I'll start Rhino again. Launch Grasshopper. I'll try to relocate my file, which is over here. Now, as soon as you start Grasshopper, you'll see this option, which is the most recent file. So that's really helpful. Now, when I bring this in and I set, I can only see one line, whereas we had set this to 2 line. Now, what happened? Why are we only seeing one line, whereas the definition says 2 line?
Because the other point that you had, you selected on Rhino ka file.
Yeah,
So
it was
you
a
did not save.
reference. Yeah,
you did not save that file.
it's a reference file. Yes. So whenever you are referencing something from Rhino window, a basic geometry to work with, set one point like this. If you're using a geometry and referencing it, you need to ensure that the Rhino file, which is used as a reference, is also saved. And you need to open both of them together for it to work. Otherwise, all the referenced components will be confused as to where to take the input from. If you don't want to go through the hassle of saving the Rhino file as well and opening the two of them together, because it can become a bit tedious at times, the other option is to store this data into this container component. Currently, the data is being referenced whereas you can internalize it and store it. So if you select this point, right click on it and go to this option called Internalise Data, that will store the data and keep it stored in this. Now, even if I delete this point, the point is deleted, and that's fine because the data is stored within this. Okay, so that's how we control and store things over here. All right. Couple of things that I want you to understand is Grasshopper works in a linear flow. So you will have your starting point and then you will pass it through a operational component. It will give you an output which will go into another component and so on. It will keep building up like that and you will have a large definition. I've seen a lot of times that students and a lot of professionals as well, they end up working in a way where you have your output and then they tend to take their inputs uh, in this manner, which will result in a lot of confusion. So right at the onset, I want you guys to get into the habit of organizing your definitions properly. You need to keep it in a linear workflow. You need to keep it aligned. You don't have any shortage of space. You can zoom out as much as you want. You can use as much space that you want over here, but keep everything flowing in a forward direction. Okay. I'm saying this because you will have issues further on and you will be showing your scripts to me. I will not entertain any scripts and I will not address any queries if I see jumbled up wires everywhere. Okay. It's very hard for me to understand. It's very hard for you to understand as well. Okay. So keep that in mind. I'm going to be using an additional plugin called bifocals, which is to help you see the name of the components that I'm using. You don't need to install this. It's mostly for you to just see the components I'm using so that it's clear to you. But if you find this helpful, you can install this plugin as well. Okay. Next set of things that we'll do is we'll see how to manipulate these geometries. There are three different kind of things that I want to cover right now. That's move, rotate, and scale. How do we move something in Rhino? What's the step-by-step procedure for moving something in Rhino? I have a line. I want to move it. So I choose the move command. It says select object to move. I selected it. Then what? I choose a direction to move it in, right? I move it like this. I move it like that. However, how do we tell this to Grasshopper in numerical terms? Can you think of a data type that will help us convey this? Let's bring up the concept of vectors. Vectors are mathematical quantities, you can say, which have two properties. They have direction and they have magnitude. If I have a line which is at, so if I go to construct point, if I have a line at a point at 0, 0, 0, and if I want to move it to 10, 0, 0, move it and not reconstruct it, okay, mind you. I'll bring up the move command, which is under transform. Move. It requires two inputs. It requires the geometry itself, which is this, and it requires motion. And if you read the input, it says it needs a translation vector. So vector, like I mentioned, it has location and it has direction and it has magnitude. So let me go to vector tab, vector, and vector XYZ. Vector XYZ is very similar to construct point. It will ask you the X parameter, Y, and Z, and the input required are numerical. So I will copy these three, paste it over here. That's the X, Y, and Z. I'll change this to 10 because I want to move it in the X axis by 10. I'll change this to 0. I'll change the Z to 0. Now what do we get? The output is a vector, and see the output the way it has been shown over here. It says open curly bracket 10, 0, 0. That's the way vector is defined. If you want to visualize how a vector looks, we can go to display, vector, vector display. Vector display requires an anchor. Now let's just look at this component first. You see this component has inputs and it has this zigzag edge on this side. This means that this component will only take an input and do something, mostly in terms of displaying some geometry and not necessarily have an output. Okay. So we want to see the vector in relation to this point. That will help us understand where this point will move. So this is the point, which is the anchor for the vector and the vector itself. And that's what we have. So we have a vector which is pointing towards the X direction because the value set for the vector is 10, 0, 0. You can think of it in this manner. You plot 10, 0, 0 on your coordinate system. So if that's the X and that's the Y, you have 10 over here, 0 is again over here, and 0 in the Z direction is also over here. And then you draw an arrow from the 0, 0 to this point. And that is our vector. So the direction is from the origin to this particular point. That's defining the direction of our vector. And the magnitude or the length of our vector is the length of the line between this point and this point. This concept is very important. Everything else that we're going to do is going to be based on this. So is this clear? Yeah. That's why the output over here is a vector and the length of that vector is 10, 10, 10. If we use this vector with motion, it's going to move the geometry in that direction, and the output that we get under geometry point is a point over here. Now, if I were to change this to 10 and 10, I want someone to use the annotate option and tell me where the point would come. If I change the X to, if I keep the X to 10 and Y at 10, where would this point go? Okay, and what's the vector direction? Can you draw that? Great, awesome. So let's change that to 10. Okay, great. What if I want to create a point over here? How do I define that vector? What are the inputs required?
A negative x and a negative y.
A negative x and a negative y. So how do I make this slider go to negative, because this is ending at 0? So we go to edit, change the minimum value to -100 so that we have a lot of options, and then double click on it, type -10. So that's the negative x. And if I connect the same slider over here, that's negative y. And let's bring the z into play as well. So that's how we move the point as per the vectors. Let's look at rotate. How do we rotate something? So let me bring this to 0, and that's the point. And let me use these two to create a line. So I'm going to create a line. So I go to curve, primitive, line 2 points. That's the start point and that's the end point. So we have a line. Let's try and rotate this line along this point by 90 degrees. Okay. So we go to rotate. In fact, before doing this, we use -10 and -10 to create a vector in the opposite direction. Just wanted to cover another way of doing that. So if this is 10 and this is 10, and if you want to reverse a vector in direction, there are two more ways to do that. You may either go to vector. Under the vector tab, you have a lot of different ways of working with vectors. So you can select something called reverse vector. Reverse vector will not change the magnitude of the vector, which is the length of the vector, but it will change the direction to completely opposite. So we pass the vector through this, and the output, let's see the output as a vector display first. So we go to display, vector, vector display. That's the anchor point, and that's the vector, and that's the vector reversed. So our original vector was like this, and now it's like that. So we can use this as well. So that's one way of reversing a vector. The other way of reversing a vector is to multiply. So let me go to math, operators, use multiplication. So that's multiplying a vector with a number which is -1. Either I can use a slider to give it an input of -1, or I can bring up a panel like this, double click on it and type -1. And that's also good enough. And you'll see that the output is -10, -10, and 0. This is called scalar multiplication of vectors. Scalar because it is only multiplying the number with these numbers. It's not changing the magnitude. Unless, I mean, it can change the magnitude if I change this to -2. It will change the vector to -20, -20. And you see now the point is being formed over there. So 3 ways of manipulating a vector. Let me just keep it to reverse vector. Yeah. And we have this line. Now let's try and rotate this. Rotate requires 3 inputs. It requires the geometry, the angle, and the plane. So the geometry we want to rotate is the line. The angle we want to rotate is how much do we want to rotate this? By 90 degrees. Now there are 2 ways of giving an angle. By default, Grasshopper, or for that matter, any programming language which deals with geometries, understands angles in radians. You understand radians, right? How much is 360 degrees in radians?
2 pi.
2 pi. Yeah. So 90 degrees would be pi by 2. All right. You don't have to remember the value of pi. There is an input is somewhere. I always have to look for it. I think it's in parameters. Wait. Okay, so it's in maths, utilities, pi. Okay. Now factor is the input by which you want to multiply pi. Right now we want to multiply it with 0.5. So I will multiply it with 0.5 and enter. That's the angle. Third input is the plane of rotation. Now some of these inputs have a default value right at the beginning. So when I hover over this without giving it any input, you can see that it already has a default value, which is one locally defined value, world xy. World xy is the terminology used to describe a plane with the center at 0, 0 and the x and y coordinates as per the x and y of the grid or the default settings. Can anyone explain what a plane is? I think we covered this in the last class. What is a plane?
A surface through which two lines pass, which contains two lines, basically.
A surface that contains two lines. Okay.
Yeah.
Plane is imaginary. It's endless, it's seamless, it's unlimited. Okay, it's used to explain the coordinate system on which you're working with. All right, and it's not fixed, you can keep changing it. So this plane is defined with its center point over here. As you can see, this green grid over here with an x and y in that direction. And that's why it's using this point and this plane to rotate over there. If I change the plane and bring the center point over here, what do you think will happen to the rotation of this line? Will it still give me this output?
No, sir. The new location. Yeah.
Could someone draw what will happen if I change the line? Or change the plane over here? Yeah, that's what we'll get. So let's try and create a plane at the center over here. To find this midpoint, I will take our initial point. That's our vector. And I'm just going to move this aside and I'll make some more space for us to work. I'll also space this apart. I'm going to take this vector, and because I want a vector in the same direction but at half the distance, I'm going to use scalar multiplication, where I'm going to use the math operators multiplication. I take this as the input A and I use a panel. So a shortcut for accessing a lot of these commands, because I keep on using it and I'm using it by default without explaining it. So let me just explain it. When I double click on the screen, you'll see this enter search word option come in. When you get used to the toolbars and you know the commands, you can use this as a shortcut to access things from the menu. So currently I'm deliberately trying to access everything from the toolbar like this, but the shortcut would be to double click and just type whatever you need. So I can type panel and I can get a panel. I want to draw a line, I can type double click, type line, and you'll see various options to draw a line. Select the one that you want and you can bring it up. Okay. So I have this panel, I'm going to multiply this with 0.5. And that goes in over there. I'm going to use the move command again, and I'm going to use a different motion. So I have a center point over here. Now I need to figure out a way how I can move this plane over here. There are two ways of doing that. Either I can create a plane over here and then move it using the move command. So to do that, I can go to vector. Under vector, we have a entire section for planes. And you have the default planes over here. You have the default XY plane, XZ plane, and YZ plane. I'm going to bring up the XY plane. And it requires an origin. So the origin point is the starting point. If I do not give an origin value, it will still give me 0, 0, 0 as the default value. But luckily, our construct point is also at the same location. So that's the origin. And the plane goes as an input over here. So now the plane has moved to this point. And now if we use this plane as an input for rotate, it's going to rotate the point or the line in this direction. Okay. If you're not comfortable with using radians, you can also use degrees and work with degrees. To work with degrees, you can type in 90. So you can copy a panel and just type in 90. And right click on this, you will see an option called degrees. You need to turn that on and you will see this icon. This icon is a visual representation that this input type has changed to degrees now. You can use this and that will work just fine. Mostly a lot of our components will work with radians and not all components have the option of working with degrees. So it's better that you get used to working with radians, but until that time, you can use this as a workaround. Okay, I'm just going to set this back to angle like this. All right, so we have move, we have rotate, and you can see everything is being overlaid over here, and the previous steps are also overlaid over here. So if we just want to visualize the final output, which is the line itself, we need to select all of this, click on the mouse wheel and disable preview, and that's it. That's the line. All right. The next thing I'm going to copy is, or I'm going to cover is array. And how do we create arrays in Grasshopper? I'm going to use our initial point to do that. So I'm going to hide everything else on the screen. I'm going to hide everything else on this screen as well. So that's the construct point. If we don't give it any inputs, the default values are set to 0, 0, and 0. It's always a good practice to start with some value. Now that's another shortcut of creating numeric slider. If you use the menu bar, you can go and select numeric slider. The default comes from 0 to 10, 0 to 1. Or you can double click and just type in any number. If I type in the number 10, it automatically starts giving me an option for a numeric slider. That's how I know I have a numeric slider over here. And copy it and copy it. Now, if I want to move this point in the X direction 10 times, what do you think we'll need? Or what do we need to do? How can I move it 10 times? Should I have the move command 10 times? So that's the geometry. I want to move it in the X direction. Now this time I'm going to use unit x. Now that's the default vector in the x direction. So that's the x, and the factor is set to 1. If I want to move it at a distance of 10, I can use a numeric slider. Go to param, change this to 10. Now if I want to copy this 10 times, I will need 10 different vectors over here. The first one being at 10, 0, 0, the next one being at 20, 0, 0, the third one being at 30, 0, 0, and so on. Okay, I'll need 10 of those. And that will tell this move component that I want to move our initial points to these 10 different locations as per these vectors. Now we can manually assign these, but it's going to be tedious. So let's look at an alternate. And that's where a number series comes into play. If you go to math, if you go to set list and under sequence, there's an option to create a series. This is quite handy. This will be used a lot in our exercises. A series will help you create a series of numbers. It requires the starting number or the first number in this number series. So the first number being 0 for now. That's fine. Now the step size for each successive number. That means what is the jump between each successive number. So we need that to be 10. So I'm going to select this and set that to 10. And how many repetitions do we want? We want 10 values. So I'm going to take this and I'm going to use this as an input. Now just by looking at this, please tell me which of these can take a floating number and which of these can take a integer only.
Start and count should take a floating number, step should take an integer only. Wait, count should take integer only and step should take a floating number.
Exactly. Count should take an integer. Now, why is that? Could you also explain that?
Because it is the number of times that the series will go on for, so it has to be an integral value.
Yeah. You cannot have 9.5 times. You can only have either 9 repetitions or 10 repetitions. You can't have 9.5 repetitions. Great. Good. So I'm going to right click on this and I'm just going to use a shortcut. Either I can go to edit and set this to integer type, or if I just have to change the type, I can just do right click, slider type, and change it to integers. And this will give me an output of a series, which is 10, 20, 30, 40, 50, 60, 70, 80, 90. Now, this is where we need to start understanding the concept of list. What we have over here is a list of 10 values. And this is how you read a list. Over here, we have the hierarchy or the address of our list. This is the index, and that's the item. All right. Notice that the index of every list starts with 0. Okay, this is important. So if a list has 10 items, it will have index from 0 to 9 and not 1 to 10. We can use this to replace our x and y coordinate. So that's the x coordinate replaced. And by default, we see 10 points being created on the screen. Okay. Now here's an interesting question. We have 10 inputs for X, but we only have one input for Y and one input for Z. How does it know what are the other 9 inputs for Y and what are the other 9 inputs for Z? To understand this concept, I need to bring this down and bring this down. I have to pull it out in a panel. Grasshopper by default works with the longest list understanding. The longest list understanding works in a way where if a component like this requires multiple inputs in pairs, Grasshopper will try to pair the respective index. So if I have 0 over here, it will try to pair up with the 0 index over here. If I have index number 1, it will try to pair up with index number 1 over here. But in this case, we don't have an index number 1. So because this component will fail if it doesn't get 3 values, it will not create a point. This list will try to match the number of items in this list. So this list has 10 items. It is going to repeat this number 10 times. So it's going to get 0 in all the other 9 index. And that's how it creates their respective pairing. And this is called the longest list method. And by default, Grasshopper is enabled to do this. If I have to replace this 0 with another number series, let's see what that will result in. So I'll take the series. I'll change the starting value to 5 and change the number slider, which is the step, to 8. And now we have a second number series, which is like this. You can bring it up over here. So by default, we are creating 10 points in this manner. Now, this is constructing a new point. If you were to move this point into 10 different positions, we would create our initial point at 0, 0, 0. Take this series, move this 10, create 10 vectors using these numbers, use the move command, that's the geometry, and that's the motion vector. Now we have 10 points on our screen. Is this bit clear? You can just give me a thumbs up and I'll understand it as a sticker, that's fine. Great, okay.
Aman,
Yeah,
what if we have two series for two coordinates, but the count is different? Like, let's say one has 10, another has a 7. What kind of?
okay, great question. Let's try that as well. So I'm going to do that over here. So I have, I'm going to disconnect this. Now, sometimes you may want to disconnect the wires. So there are two ways to do that. Either you go to the component which has this input, you right click over here, you see the option called disconnect and you disconnect it like this. Or you can press Control and retrace the path and that will disconnect. Okay. Now you said if you have two series of different counts. So if I change this to 15 or 18, increase this. That's y, that's x. Okay. So what happened? That's point number 0. That's 1. In fact, if you want to understand how this list is drawn, firstly, we get a set of 18 points. That is, it's trying to maximize the number of points and try to follow the longest list method. Okay. Secondly, to understand which point lies at which index, we can bring up the option called point list. So it takes in a bunch of points and will write down the index right next to it. If the font size is too small, you can change it by using a number slider and increase it in size. So the points are organized in this order, and these numbers are the index of these points. So for the first 10 points, which are represented from index 0 to index 9, it is trying to match. And let me also pull up these two series. So we've got this series and the other series, which is of 18 numbers. So this has been paired together. This has been paired together. So the first 9 have been paired together. And you can see that over here, 7790, 6980, 6170, and so on. Beyond this point, when it does not have equal numbers or any relevant item in this index, this last value has been repeated to match the length of this list. So that's why you see 77 being repeated, whereas y remains, or y keeps changing because you have different values over here. So at this point, x value remains constant, that is 77, and rest of it starts going up. Okay, so it will always try to create the longest list. Let's see this with another example where I create, let's say I create 2 curves. I'll reference these curves in Grasshopper by going to param, geometry, curve. Right click, set one curve. Again, bring up another curve component. Right click, set one curve. Okay. Now I can take this curve and I can divide it into certain number of points. To do that, we can go to curve, division, and there are multiple ways of dividing it. I will use the simplest one, which is divide curve. It requires 3 inputs. And we need to give, we don't need to give all 3 inputs, only enough inputs that it changes from orange to white or that silver color. So the first one being the curve that you want to divide. So that's the curve. And the next one is the count. How many divisions do we want? So by default, it is set to 10. I'm going to bring up a numeric slider. I'll copy this one. Change this to 13 for now. I'll copy this divide curve again. That's the other curve, and we have 13 over here. Now, let's create a line between these two. So we go to curve, primitive type, line between 2 points. That's the start point, that's the end point. And we see all these lines created. Let me bring up the point list so that we can visualize how the points are arranged. So it's both of these curves have a starting point on this side and an endpoint on that side. And that's why we can see this line being created in this manner. Now let's say take the same argument where if the number of divisions in both the curve are not the same, that means I have 10 divisions over here and I have 15 divisions over here. You can see the same logic coming into play, wherein as long as we have respective index in both the lists, it tries to match it. And when there are no more items in a list to match the additional items of the other list, it will repeat the last point those many times. And that's why you see a line being created from this point to match with these extra items. Now, there are a couple of things that we can do with a list. One interesting thing being, if I go to set, under the list option, there are all these different ways you can manipulate a list and do things with it. By default, our list is organized in this orientation. I can go to set list and reverse the order. So if I go choose reverse list, take the points in and choose this option. You see the last one has become the first one. The ninth one has become first one over here and so on. If I use this as an input, we can change the way these lines are drawn between. Okay. Now, a lot of times when you're modeling, we come into a situation where we have a curve and we have a point and we want to create a line between the curve and a random point over here. And we rely on snapping methods in Rhino. So we have different kind of snapping methods like the nearest point or the tangent point and perpendicular and things like that. In Grasshopper, if I have a curve, I'm going to hide all of this. If I have this curve, I can identify a point on this curve using two methods. One is to go to curve and go under the analysis component, and you have different ways of analyzing a curve. One is evaluate curve. Now, evaluate curve takes in the curve that you want to evaluate and a parameter value. Now, this parameter value you should keep between 0 and 1. So bring up a numeric slider and set this between 0 and 1. And under the curve component, you should right click on this and reparameterize. Now, what this does is it takes this entire curve and it will reconfigure it in a way where it will understand the start point having a parameter 0 and the end point having a parameter 1. And every other point on this line can be derived using a number between 0 and 1. So if I choose a number 0.25, that is taking the quarter length of this line or this curve and identifying a point over there. If I want the midpoint, I can change this to 0.5 and it's getting me the midpoint over here. You can just move the slider and you can identify any point on this curve. Okay. The other way to do this is called point on curve. I'm just trying to locate it. Yeah, this one. So it requires a curve input and there are default settings. So if you right click on it, you can either find the start point or the quarter point or 1/3 midpoint, whatever. So you have these default settings over here. If you want finer control, you can use this. By the way, this little node that you see, it's called relay. it is used to organize your wires. So if you don't want your wires to be in a very messy state, you can double click on a wire like this. And this will help you organize the wires. And you can also write that this is a curve input, and that's how it works. So these two components will help you identify point on a curve. So let's use all these commands that we have learned right now, and let's create a shell geometry out of it. I'm going to use these 2 points or these 2 curves. I'm going to use this. Get rid of the reverse list. You have this line. What we're going to do is identify the center point of all these lines. Then move them upwards in Z direction. And then create an arch using these 3 points. And once we have these series of arches, we will loft them. Okay, so we have these lines. These lines are again in the same order as the point list. So bring in the point list over here. That's the point, and that's the size. Yeah. Now on this line, if I have to find the midpoint, I will bring in the point on curve component. And that gives us the midpoint. If we analyze the point list of our midpoint, it's again following the same order in which we have our initial points. Let's move these points in the Z direction. So we have 11 points. Let's create a series of 11 numbers that will actually, if you want to move it, bring the move command, that's the geometry. And the motion by default is 0, 0, 10. That is a vector of magnitude 10 in the Z direction. So if I have a constant value over here, all the points will be moved at a uniform distance. So let's go with that for now. I'm going to choose the vector Z direction and change the maximum to 50 so that we have a point somewhere over there. And now we need to identify a way to create an arch using this. So I will go to curve and I'll see what can help me. I'll go to spline and in the primitive, there is arc 3 point. Let me use that. So arc 3 point creates an arc through 3 points. It's self-explanatory. It needs point A, point B, point C. So for each of these lines, I'm going to use the point on this curve as point A, the center point as point B, and this point on this curve as point C. So point A can be derived from here. That's point A. Point B can be derived from here. And point C can be derived from here. And because it is getting too cluttered, hide everything. Okay. We can add a bit of complexity to this by not having a uniform Z value, but change it as we move ahead. So rather than using a constant Z value, I need to create a series. So I'm going to bring up under sequence series. The start value, I will start with a value 5, a step count of 5 again, and the count. Count would be the number of curves that we have, which we have as 11. But I don't want to feed it manually because if I change the number of divisions of this curve, I'll have to keep changing the count as well. So I'm going to link it with this parameter over here. So if we divide a curve with 10, we get 11 points. I'm going to use a mathematical operator to add 1 to this. And the result is 11. If I bring this up as a panel, I can see 5, 10, 15, 20, and so on. If I use this as an input, I see some variation happening. Okay. Now let me try and loft this. So I have these set of arcs, and we covered last time in Rhino that if we have a set of arcs or a set of curves like this, and if you want to loft between them, you can select 1, 2, 3, how many ever we have. It creates a loft between them. So let's try that over here, wherein we have all our arcs in the right order, that is starting from here and ending over there. We can go to surface, freeform. We find the loft command. It needs an input of curves. Options is again something which is optional at the moment, and that's the surface we have. We can increase the number of divisions by changing this value. So because I want to keep the same number of divisions between these curves, I'm going to just go with a single slider. If we increase this, I can change the complexity or the finesse of this curve. Change the starting value as well. Now let's try another thing where I have one curve like this and the other curve which is lower in height. So perhaps the center point, this one, the first one can move by 10 units, the next one can move by 5 units. Then the third one can move by 20 units. The fourth one can move by 10 units. So I don't want a straightforward number series, but a number series which keeps varying. If you want to do that, what we can do is change our number of divisions to an odd number, which is 19. That way we will have 20 points. And now I'm going to take this and divide this by, so we go to operators, division, we divide this number, bring up a panel, divided by 2. Okay, so we have 10. What I'm trying to do is create a number series, which will give me a number series for every odd number curve, and then a number series which will give me the height for all even number curves. Okay, so that's the number series for all the odd number curves, and I will copy this and create another series for all the even number curves over here. Now, if I want to join these two lists, I've got 10 outputs over here, and I've got 10 outputs over here. I need to join them into a single list. Now, when joining this into a single list can be done in 2 ways. If one way to do it is to go to set, go to trees and choose merge. Merge requires the data tree or the list that you want to join together. So that's the first one, and that's the second one. The issue in this case with merge is that when we merge it, it will put these numbers as the first 10 numbers and then these 10 as the next 10. Whereas what we want is to have 23, then 14, then 28, then 18, then 23, then 22, and so on. So we want each of these index to be arranged alternately over here. To do that, we will use another method which is called weave, wherein I take one list over here and the other list over here, and it will give me an output which is woven. That is, it takes 0 of the first list, then 0 of the second list, and then 0 of the one of the first list, and then 1 of the second list, and so on. Now I have 20 values over here, which can be used as a unit Z value, and that's the shape that we have. Okay, and I can keep increasing this. So let me change this to 100. Let me set this to odd. We can also do this by creating 2 circles. So that's circle number 1. And actually, let me just move this aside. I'll create circle 1 over here, and I'll create another ellipse over here. Set one curve. Set one curve. And this has gone haywire. Let me reduce the number of divisions. I'll draw these again. Because it's a closed curve now, the value that you set over here is the number of points that you will receive after the divide curve. Now let's see why that's happening. When we have an open curve, and if you want to divide it into 9 segments, 3, 4, 5, 6, 7, 8, 9. So that gives us 10 points in total. Whereas when we have a closed curve and we divide it into 9 segments, 2, 3, 4, 5, 6, 7, 8, 9. So we have, sorry, we have 10. So I mean, ignore this one. So closed curve will give you equal number of point outputs after divide curve, and a open curve will give you 1 additional point. So because it's a closed curve now, this addition is useless, and that's why we're getting the error over here. By the way, a component which shows red flag like this has some kind of an input error, and it can be read over here in this balloon, which says loft cannot be constructed. So in order to fix this, I'm going to get rid of this value over here and just join it like this, and also set this to an even number now. To remove this as well, and that's the input. Yeah. So we have a geometry like this where I can manipulate the curve however I want to. I can also increase the number of divisions. And if you want to close this, under the loft options, if you right click on it, you will get loft options over here, and you can select closed loft. Closed loft will close this gap. So it will loft between this last curve and this curve, and it will close it. So we can select close loft option, commit, and yeah, that's the output that we have. This output can also be colored for easy visualization. So if I go to a rendered viewport, I see this green colored output in this viewport. I can display it using custom colors by using a preview option where we have the custom preview. It uses a geometry. That's the loft over here, and the material. For material, we use a swatch. So we can go to param input and we can use color swatch, and you can choose whatever color you want. So you can just double click on it, select the color that you want to use to visualize it in. And you also see all these additional lines. So let's hide all of this, and there you go. All right. Any confusions as to what has happened over here, and is the weave command and the merge clear to you?
Yeah, this part is clear, but I had a doubt in the upper part. I
Mhm.
wanted to know the function of the relay and evaluate curve thing.
Okay, sure. Let's do that. That's interesting, and let's uh, I'm going to create a curve like this. Set one curve. That's our curve. Now evaluate function, evaluate curve, takes in the curve that you want to evaluate, and it requires a parameter input. Now the parameter is usually set between 0 and 1. And like I mentioned earlier, whatever curve you take, every curve has a direction. The direction is defined from the start point where it was created and the end point. The way I had drawn this curve, this is the start point and that's the end point. And there are many points in the middle which together create this curve. So when we reparameterize a curve, what we are saying is that whatever is the parametric value of any point on this curve, it should be reparameterized in a way where the start point is set to a value 0. That is, the parameter at the start point is 0 and the parameter of end point is 1. We do this because suppose we have 3 points. Let me create 3 curves of different lengths. Let me create. Okay, we have these 3 curves and I'm going to set multiple curves over here. Rather than creating one curve, I'm going to set multiple curves. So firstly, I clear the values and then set multiple values. In fact, let me also change the direction of a curve. So this curve is being created in the other direction. So set multiple curves. Yeah. I have 4 referenced planar curves. If I do not reparameterize this and I choose a parameter between 0 and 1, what you'll see is that you don't see any change in the point when I move the slider. That is because by default, it's choosing the length of this curve as the parametric domain of this curve. That means if the length of this curve is 100, for example, it is going to create parameters between 0 to 100 over here. If the length of this curve is 150, it's going to create parameters ranging from 0 to 150, and you get the drift. It makes it very difficult for us to work with multiple curves in the way where if you want to find the center point of all the curves, we'll have to find the parameter of all the curve, and then that will become curve specific. So to get rid of that specificity, we reparameterize all the curves between 0 and 1. That means now whatever is the length of a curve, we don't care about the length, because for us, the start point is 0 and the end point is parameter 1. And any other point between or any other point on this curve will be between 0 and 1. And now when we use a slider, we know that at 0, it's going to take us to the starting point of that curve. When we take it to 1, it will take us to the end point. When we set it to 0.5, it will take us to the approximate center of this curve. And that helps us work with all these curves in a similar fashion. Does that clarify it?
Yes, but I wanted to know, you use this relay thing. What is?
Relay. Okay, relay is just for me to organize the wires. So I don't like wires crossing like this. It makes it very confusing for me. So this wire crossing like this. So relay is a way to manage our wires, how it's flowing. So when I double click, I create this relay, which is like a optional node, which can be deleted when you double click on it. And it will help me organize the wire in a neat way. So I know how it's moving. And just to know where this data is coming from, I can also write the name that this data is coming from point. So I can just rate it point. So it's just a optional way of organizing your script. You don't have to use it. I use it quite often. So I'm just letting you know because you may be confused later on. Okay.
Excuse me, sir, I had a doubt.
Yeah.
So you used a component called weave, which had an input called pattern.
Yeah.
So could you like explain a little bit
Sure.
about that? How do you input values?
Sure. Let me take these series and I will bring it over here. Pattern is governing how we stitch two lists. So our list number 1 is over here and a list number 2 is over here. By default, the pattern is set to 0 and 1. That means it will take, so our list number 1, which is coming from here, or let me just call it list number 0. So that's list number 0 and list number 1. The pattern over here suggests that it will first take an item from this list and then the second item from this list. Then this list and then this list. That's the pattern it's following. Now, if we change this pattern to, I bring up a panel and I change this pattern to 0, 1, 1. Now, another thing I forgot to cover is whenever you are giving multiple inputs in panel, if you're giving a single input, that's fine. But if you're giving multiple inputs, you're creating a list. Like I'm giving 3 inputs right now, I'm creating a list of 3 numbers. When you do that, you need to right click and set this to multi-line data. If you do not do it, it will give you an error whenever you use it. Okay. So always convert your panel into a multi-line data type whenever you give more than one inputs. So if I have this as an input, and let us compare it with a normal one. Yeah. So this one takes the first element for 23 over here. And then 1. Wait, 0. It takes the 0 from here. Then it takes the 1 from here and then takes the 1 from here. Now I don't know why it's skipping 28. It's trying to make sense of this. Now, usually when we use weave, I have never come into a situation where I have changed the pattern of this. I was assuming that by changing the pattern, it would give us 0 from this one and 1 and 1 from this one, but that's not the case. So I think I'm not clear about how the pattern thing works. But if you leave it to default, the way it is, which is 0 and 1, it will help you weave the two values from either list alternatingly. Actually, wait, no. Okay, sorry. I was right in my assumption. Wait 1 second. Yeah, so it does work in this manner where if I have 0, 1, and 1, it takes 0 from here. That's the first list. Then it takes 1 and 1. And then it again takes 0. And then it takes 1 and 1 from here. Then it takes 0, and then 1 and 1, like that.
So why isn't 0, 1 and then 1? And why is it 0 and 1, 1?
Sorry, I'm confused. What are you? What's your question?
Why is it not taking the 0 and 1 from the first list and then taking 1 from the second list?
Because I've set it to 0, 1, 1. 0, 1, 1 means the list number. It's referring to the list number and not the index number.
Okay.
Okay. So it's saying that take it from list number, take one index from list 0, not index 0, list 0, and two numbers from list 1.
All right. So if I wanted two indices from the first list, then I would have to input 0, 0, 1.
Yes, let's try that as well. So let's do 0, 0, 1. So now we can see 23, 28, and then 14. And then 33, 38, and then 18. Yeah, it works the way I thought it does. Honestly, I don't use this weave component much because there are other ways of doing it, and that you will learn slowly that Grasshopper allows you multiple ways of addressing one problem. But at this moment, I felt that weave is the right one to touch upon. Okay.
Okay, sir.
Great. So I think we have almost come towards the end of today's class. If you have any specific queries regarding any of the things that we have done, I can take it up in this 5 minutes. Otherwise, I would like to leave you with a practice exercise that I would like you to try till Friday. Okay. Before that, any other specific doubts regarding what we have covered till now? The number series or basic geometries? Okay, I'm assuming that to be a no. So let me come to the simple exercise. May I request everyone to just turn on the webcams? I mean, we're just about to finish the class now. Come on. All right, so the components that we have just covered today and the workflow and the different things that we've covered, I want you to use that and deduce a method how you can get the basic line work to create these forms. And the forms that I'm showing right now are specifically chosen so that you can derive it using the simple techniques that we have covered till now. So again, coming our way back to the Absolute Tower by Mad Architects or the Twist Museum by B.R. Kingles. If you have to talk about this particular tower, how do you think you can approach this parametrically? If one of you would like to just walk me through the workflow.
So to me, it looks like there's an ellipse which is being rotated as it moves upwards.
Okay. So if I have to talk about, yeah, you're absolutely right. That means you will, let me come to the canvas. So you will take an ellipse. That ellipse will be moved in which direction? Z direction at a certain height. So you will create a number series to move it at a certain distance. You'll also create a series that will define the rotation, right? And first you will move the geometry, you'll get an output, and then you will rotate these geometries. So that's rotation with a certain number of angles. And that will give you a basic line work of all the ellipses which are rotating. Okay. Same thing you can approach for the twist museum as well. You have the basic rectangular geometry which is being rotated. The trick would be to find the axis of rotation in both cases. You need to be specific about the exact axis and creating the center points and finding the right plane for rotation. So I want you guys to try it because you will encounter problems. And once you encounter problems, you will have questions that we can take it up in the next class. So you need to practice this. I'm not asking you to make surfaces, but just to quickly cover how to make a surface out of this. If you have a curve like this one, well, let me just take this curve and hide everything else on the screen. If you have this curve, you can go to surface, freeform, and choose boundary surface. And it needs an edge. When you select it, it will make it a surface. So if you're able to derive all your ellipses, you can put all your ellipses through boundary surface, and that will give you surfaces for those ellipses, or squares or rectangles, whatever you're working with. So I need you to try this exercise and get me those moved geometries and transformed geometries in terms of rotations. Okay, that's your exercise till the next class. It may be Friday, I will let you know. Okay. All right, so that's it from my side. Please post whatever you have explored in Rhino by on WhatsApp. Just a snapshot will be fine for now. And please keep your Grasshopper definitions clean. I don't want to see messy scripts. It's a bane in our field that people don't put in effort in organizing it. And I'll see you on Friday. Yeah, great. Bye.